and welcome. This is video 5 of compound inequalities. Okay, just like compound words that are made up of two different words, like dog, house, compound inequalities are made up of two inequalities. Sometimes you'll see more, but for us, we're just going to be looking at two. Okay, so we're going to look at a couple examples. If I had something that looked like this. Alright, so this looks like x is less than 5, or less than or equal to, because of that closed circle. So I'm going to say x is less than or equal to 5. And then we could have something that maybe looked like this on our graph. Okay, this would be x is greater than 10. So here on this number line we could have x is less than or equal to 5 or x is greater than 10. On our next number line we've got an open circle and a closed circle between 1 and 4. So what this could mean is if we kind of forget about the 4 and just look at the 1 in the direction the graph is going, that would be greater than 1, okay? So here we would have x is greater than 1, and what else is happening? Well, if we kind of forget about the 1 in that circle there, well, everything would be less than or equal to 4. So x would be less than or equal to 4, okay? So those are what compound inequalities look like. Most of the time they're either on the ends or the middle, okay? And so we're going to just we've got kind of a lot of examples, but I just wanted to show you guys all the things that could happen and different types of these compound inequalities. All right, so for our first one, we've got two different equations. It's an OR statement, so most likely it's going to look like this, where it's colored on the ends. So let's go ahead, solve one of these at a time, okay? So forget about this guy and just solve one of these, okay? So here, this is a plus 4, so we're going to do the inverse operation, which is minus 4. So we've got negative x is less than or equal to negative 7. Now we're not done yet because this is a negative x. I like to think of it as there is a little invisible 1 right here. Okay, there's 1 there, so we are going to divide by negative 1 on both sides. And remember, when that happens, we flip our inequality sign. So I've got x is greater than or equal to 7. All right, so we'll hold off on our graph for now, but that's one of our answers. Now, for this next one, we only have one step, just divide by 2, and we've got x is less than 5. All right, easy. All right, and so we can go ahead and we can graph this, okay? So I like to make my graphs very, very simple. I've got a 5 and a 7. I just put my two numbers down, okay? At my 5, it is a less than, so it's going to be just an open circle, and I am shading every number less than 5. Okay. For my 7, it's a greater or equal to, so that would be a closed circle, and it's greater, so it's all these numbers that are bigger than 7. Okay. So not only do these parts matter in your answer, but you need to have a graph as well. Okay. All right. Moving on. Here we have an AND statement. So again, solve one of these equations, then solve the other. Okay. So I'm going to subtract 9 from both sides. I've got negative 21 less than or equal to 7x, and then I'm going to divide by 7. So I've got negative 3 is less than or equal to x. Now, like to rewrite this. I don't like it really when the variable is first and the constant is first and my variable is second. I would much rather have it the opposite way. So just kind of flip it around. So it's going to be x is greater than or equal to -3. All right, now let's solve our second problem. Subtract 9 on both sides. We've got 7x is less than 7. And when I divide by 7, I get x is less than 1. All right, so here I'm going to put -3 on my number line and 1 on my number line. Okay. At -3, I'm going to have a closed circle because it is that or equal to, and it's going to the right. I'm not going to color everything. I'm just going to go a little bit because I need to know what's happening with this 1. Now with this, it's less than. So it's an open circle and it's everything less than 1. And it says and so we want both of these things to be true. We want it to be greater than -3 and less than 1. I like to think of this as those signs when you go to an amusement park that say you have to be at least this high at least this tall to ride this ride, but you also have to be at least a little bit tall because we can't have little infants riding on a roller coaster. So it has to be between two numbers. All right, moving forward. Now, this one looks way different than what we've seen. This was a compound inequality, and it's the same thing as an and, they just squashed it all together. Okay, so we're going to solve this pretty much the same. It's just all kind of one thing altogether. Okay, so we're looking at this inside section with our variable, and we want to get the variable by itself. So when I subtract 3, not only going to do it on this side and this side, but you do it on all 3 sides. Okay, what you do in the middle, you do on the ends. So here I've got -5 is less than or equal to x is less than 6. Okay, and that's my final answer. Some of us might find this a little hard to read at first, so I like to break it into 2 different equations, or 2 different inequalities. So just take the -5 and the x. Okay, that breaks down to -5 is less than or equal to x. Now I like to rewrite it, so it's x is greater than or equal to -5. Okay, when we break down the 6, this is a little easier. X is less than 6. Okay, now we can graph our 2 answers just like we did on problem 2. If you think that writing it in this one big inequality, if that makes sense to you, then go ahead and do that. This is just whatever makes sense and is easiest for you. So here we've got a closed circle on -5 and an open circle on 6, and we are coloring in between. Okay, and that is what our true inequality looks like. Okay, we've got 3 more problems. Okay, here's another or statement. And let's go ahead and let's solve this. So we've solved this, we've found our 2 answers. Okay, and time to draw our dots. So this one says x is less than 4. So an open circle at 4. We want everything that's less than 4. Okay, that'd be going all this direction. Now it also says x is less than -2. So we don't need to put an open circle there because -2 is covered in negative being less than 4. Okay, so this is an or statement that just goes one direction. All right, and the reason we don't put an open circle there is because -2 is included in this first inequality. Even though -2 isn't included in this inequality, in our second one, it's already covered. Okay. All right, we've got another compound inequality. So go ahead and we're going to go ahead and solve. So first we solve this by adding 1 to all 3 sides. And we've got one extra step. Divide by 2 on all 3 sides. So we have -3 less than x is less than 5. Now, if this makes sense to you that I just need to color between 3 and 5, then that's great, okay? If not, you can separate it into those 2 equations, or those 2 inequalities. And x is less than 5. Okay, and with this, we actually have 2 open circles, and we are shading in between. Okay, now, this is our first word problem that we've been doing out of these examples. So don't shy away from word problems because they're just the same, okay? It's the same stuff, just a few more words, okay? And if you don't do it, then my dog Susie's going to get mad. All right. So she needs between 510 and 540 calories. Her food that she gets in her little dog bowl is 370 calories, and she's a pretty good dog, so we'll give her treats, but they're only 15 calories. So we want to know how many treats can we give her and still be between her calorie intake. Because if she eats too little, she'll be hungry and sad, and if she eats too much, she'll be really, really fat, okay? And we want her to be active. All right, so we've got to make an inequality. So I like to start with, what can she eat? We want it to be more than 510, but also it's got to be less than 540. So we want somewhere in between here. Okay. And let's go ahead and say that she can have 510 calories. And she can have 540. So we're going to make those or equal to's. All right. So her food is 370 calories plus however many treats that we want to give her. Now we put a variable here. Let's kind of show what that variable means. So let's say x is the number of treats. So we can give her any number of treats, but they're all going to be 15 calories each. Okay, so we can solve this by subtracting 370 on both sides, so we can see how much we have left for food. All right, so go ahead and divide by 15. And we get 9.3 less than or equal to x is less than or equal to 11.3. Okay, now let's just assume that we can't break these in half. Okay, we can't break these and give her a third of a dog treat. Okay, so for this we're going to say she can have between 10 and 11 dog treats. If she had 9, that wouldn't quite be enough to get her to her calorie, to that 510. So we're going to say somewhere between 10 and 11. So that's the number of treats that Susie can have. All right, great work. This has been Compound Inequalities.